So in this question we've got a pulley system which is set 1.5 metres off the ground, and there's two weights dangling off the end of each side of the pulley system, one of mass 3m, one of mass 2m. And what's going to happen is 3m is going to fall to the ground, and this weight here, and 2m is going to go upwards. Now as 3m, this side x, it falls and hits the ground, this side here at y, weight 2m, will have travelled up 1.5 metres to, let's say, approximately this position here. Now when this side here reaches that position, the momentum of it going upwards and the speed it's gained will actually make it just bounce a little bit. So it's going to go up a little bit and then come back down. So what the idea of this question here is to find that distance. That's what we're going to do. So to help us on our way, we've got 5 questions. We've got calculate the tension in the strings. Now the tension is going to be pointing away from the masses and towards the pulley. So the tension will be going up in this direction. Calculate the acceleration of the system as it falls to the ground. Then we want the time in seconds it takes for this side x, mass 3m, to hit the ground. We also want to know the velocity of x as it impacts the ground, and then we want to find out how far y bounces upwards after x impacts the ground. So we only want the distance upwards, we don't want to find the total distance. So this distance here, just the distance upwards. Okay, so first of all, calculate tension in the strings. So let's set up our equations of forces. So we're going to use force equals mass times acceleration. So that's the general thing. So we resolve for all of the forces and set them equal to mass times acceleration. So let's pick what's going on at x first. So at x, the system is going to be going up in this side but down on this side. So on this side, t is going away from the travel of direction, so it's going to be a minus t. We've got the mass of the block falling down, so that's 3m times g. So that's going in the direction of travel, so it's equals plus. And then the mass times acceleration is 3m times acceleration. Now here we've got g is the force of acceleration due to gravity, which I've got set at 9.81 meters per second squared. Then here on side y, so at y, we've got travel on this side is going upwards, so t is going in the same direction, so in this case t is positive. And the mass of the block pulling down, so that's minus 2m times g. So it's minus as it's going against the travel of direction. And mass times acceleration will be 2ma. And then what we've got to do now is solve for a and solve for t. Now we've got a classic situation here with two simultaneous equations, which is what you would generally get with this kind of setup. So then we can eliminate t by adding, and then we'll have 3mg minus 2mg, which is just mg, and set that equal to 5ma. Now divide both sides by 5m and we'll get a on its own. So a equals mg over 5m. So that's just going to give me g over 5. Now g over 5, that simplifies down to 9.81 over 5, which if you put that in your calculator, you get 1.962. So that's our acceleration. Now to get tension, we can just plug this value into either of these equations. So I'm going to just plug it into this one. So I've got t equals 2ma plus, if I put that on that side, 2mg. And then let's factor out a 2m, makes my life easier. 2m, 2m, and then a plus g. A is this, which is g over 5. If I use that, it makes my calculation slightly easier. 2m g plus g over 5. So then I'll have 1g plus a fifth of a g, so that's 6g over 5. So Tm equals 6g over 5 times 2m, which equals 12 mg over 5. So G is also 9.81. So I've got 12 times 9.81 times m over 5. And that's the tension calculated. So that's the first two bits taken care of there already. So that's all good. So that's A and B already done. So now we want the time in seconds till X impacts the ground. So this is going to be using our kinematic equations. So we want to use SUVAT. So S, U, V, A and T. Always recommend writing these down first and then seeing what you've got, and then you can work out which one of the 5 formulas you need. So S is the displacement. Well, it's going to be 1.5 meters. U is the initial velocity. Well, the initial velocity is going to be 0. V is the velocity we're going to calculate. So V is something to be found. And T is also something to be found, as in that's part C. And for A, we know what A is. A is 1.962. Okay, so with that information, we can go ahead and find T by using S equals UT plus a half AT squared, and plugging in the appropriate values, and then we can solve for T. So S is 1.5, U is 0, so this term's going to disappear regardless of what time is, and then I'm just left with a half times A times T squared. So I've got a half of that, so a half times 1.962 times T squared, in which case T squared will equal 1.5 over half of 1 times 1.962. Well, that's just going to be 9.81. Okay, so then T squared, if I take the square root of that, I'm going to get approximately 0.39 seconds. So that's part C taken care of. So now we need to find V. Now with that information, now I've got T, I can use V squared equals U squared plus 2AS. So let's use that on this side. So V squared equals U squared plus 2AS. And now V is what I need, so that's going to stay on the left hand side. U squared is my initial velocity. Well, that's just going to be 0. And 2, yeah, I need 2. A is 1.962. And S is our displacement, which is 1.5. Okay, so then I can plug that into my calculator and I'll get V is approximately 2.426 meters per second. So you can do that in your calculator and take the square root of it. I'll leave that for you guys to check. So that'll be the velocity on impact. But now to the interesting bit, we want to work out how far Y bounces upwards after X impacts the ground. So as this thing moves up, the actual normal system now has come to an end because there's no acceleration acting on these by their forces. So all we've got now is Y, this 2m mass, is going up on its own weight and its own momentum, and it falls back down now due to the force of gravity. So to calculate that, we're just going to have to change the system slightly. So I'm going to write some new SUVAT values here. So now S is what we need to find. So S is that. U is my initial velocity. So my U is now this. So that's 2.426. So that's my U, that was my velocity as it impacted the ground. That's the speed that this was going up at that moment. And then V is now the velocity. Now when it travels upwards, what we want to do over that distance, when it gets to the highest point, it's going to go up and then stop very briefly. So at that point V is 0. So if I put a 0 there, my acceleration, that's just going to be gravity, so that's going to be minus G. And then T, I don't know how long it's going to go up there. I think I can work this out without needing the T. So with S, U, V and A, I can use V squared equals U squared plus 2AS. So let's write that in there. So V is 0. U squared is 2.426 squared. So we would have had that when we was working our calculation here. So that's what it is there. And then we've got 2 times gravity, which is now negative. So I left out the plus sign there because as gravity is going to be negative, as it's now going downwards away from the direction of upwardsness. So I've got -2, or upwardsness if that's a real thing, and then S. So -2GS. Okay, so now what have I got there now? So now 0 equals 2.426 squared. Well, I've got this, which is going to be 3 times 1.962. So that's going to be 5.88, isn't it? So 5.88 minus 2 times 9.81 S. So then to get S on its own, if I bring this over to this side and then divide by it, I'll have S equals 5.88 divided by 19.62, and that will give me 0.3 exactly. And that's in meters. So that's the answers to all of my questions. So that's equals my T. Actually, that's not my T squared. And then here I've got my acceleration. And here I've got my tension. Okay, so that's all of my questions answered.